No time no see.
Let's do this!
Today is day 8 of the Linux Upskill challenge. Today is a good day because we're going to learn how to use text processing tools. So by now you already figured out that we use a lot of text and files, processing those files inside a Linux environment. So let's get those concepts into something useful, and today we're going to process some text from those system files. Before we start, it's crucial that we understand the concept of data streams, because we're going to start to mess with this a little bit. When we get to the final lessons of the challenge, we're going to apply that in scripts. First, we have the input, the standard input. This is coming from keyboard, touchpads, mouses, or any input device that goes to the terminal or the console. That input goes into the running program that you're using. That running program is going to process that input and is going to return this standard output. That is what is expected to be returned, or it's going to return an error. That is a different stream. Usually both goes to this display. We see both the standard output and the standard error appearing on the screen, but sometimes you're going to redirect those streams to redirect the errors to a separate file so you can analyze later, or you're going to redirect the standard output from one program as the standard input for another. So we're going to explore that idea today. So we're back to our server. The first program that I'm going to show you is echo. Echo is supposed to print on the screen whatever parameter you pass it. So if I echo hello world, it's going to show me hello world. If I echo a variable, it's going to show me that variable. Another program to print stuff on the screen, cat. Print on the screen the contents of a file. It reads from the file and it vomits everything on the screen. Other useful command is the counterpart of cat, that is stack. That is literally cat backwards. That prints on the screen, but in reverse. The first line of the file is now the last line that is printed on the screen. Getting this idea of taking the contents of a file and printing on the screen, we can start to do more stuff with this. Let's say that I just want the first lines of a file. I can use head, that literally means the head of the file, print the first few lines. Of course, that I can give a quantity that I want of lines to be printed out. Like I want 5. I want just 5 lines, or I want 50 lines. In the same idea, I can choose to see the bottom or the tail of the file. The last few lines of the file, then I can use tail. Those are the last lines of the file. There is one little resource that is really interesting, that is I can see the file being incremented. Tail f var log apache access log. Nothing really interesting here, but if I use the server, you see that I open a browser to check on the server. You see that there's another line of log up there. If I give it a refresh, it's going to another line and another line. Okay, to get out of that, I use Control C. I can see the first lines, I can see the last lines. How many lines do I have in a file? I can use WC, that is literally word count, but it serves to count lines as well. So I want to count the lines for service. I have 417 lines. I can check that with vim. Here we are, for 417 lines. Sort. And see, it's going to show me in alphabetic order from the first character. I can use uniq to print only the unique lines. uniq is going to show more of its power when we combine it with other commands. Cut is an interesting one because we can literally cut chunks of information from inside a text file. So if I give a cat etc password, the fields are separated by a column, but I just want to see the name of the user. But the name is in Ubuntu with a capital U. This is the first, second, third, fourth, fifth field. So I'm going to use cut-d for delimitator. I want the column as the delimitator, and I want the field number 5 from etc password. It showed me only the name of the users, root daemon being, and here we are, Ubuntu. And then we get to the infamous grep. You can check out this explanation of where grep came from. In simplest terms, grep processes a text and matches with a specific pattern. So if I want to check inside my service file, if I want to check everything that came with Amanda, I can use grep Amanda, which means I want everything that is Amanda inside a file that is services. And it's going to show me only the lines that have that pattern. Interesting, huh? This is very useful. Other text processors that I use it a lot, that are a little more complex than grep, and I'm not going to touch into this. Sed and awk are also fairly used in Linux and Unix environment. So we got all of these programs. Now it's time to redirect that information between them. Remember that we just learned about the data streams and that the standard output of a program can be the standard input of another. We can do that. I can just use ls to check my files, and I want to put this information into a file, so I can repeat that and use a more than sign that is basically an arrow. Is redirecting the output of this program and is putting as a standard input of another that I can put here. I'm going to create a file list. If the file doesn't exist, it's going to create one, and if I put that on the screen, it's the same thing. I want to put the ls etc inside my list. Cat list. It's a different stuff. You see, the first ls that I have from the home directory is no longer here because it overwrites. If I want to add information instead, I have to double more than sign. So it's going to append information. So I want to append information to the list, and if I get a cat list, here we are. Hello is down here. Those redirection operators, we have a lot more than that. The big one, the one that you're gonna use a lot, the pipe. Pipe, you're going to see in your keyboard that is just a straight stick, but what it does is create a pipeline that it's just going to create a data stream between programs. And check this video out. It's going to take the output of one program and put it in as the input of another. And the task for today is to check our attackers. var log authentication log. You see that is a bunch of trials here. I want to know which of those access are for root. Grep root var log out. Those are all the root connection attempts. Now we can use something that is called regex or regular expressions. Take your time to learn this. Is really a good skill to have on your tool belt, not just for sysadmin, for programming and automation and anything in computing really. I want to check for the IP addresses that are trying to attack my server. The pattern is some numbers, then a dot, then some numbers, then a dot, then some numbers, another dot, more numbers, dot, more numbers. The idea is that those numbers, they can be from 1 digit to 3 digits. Grep. I want numbers from 0 to 9. Those numbers can be 1 to 3 digits. Then I have a dot, and this is the first octet, the first part of the pattern that we have. This is going to repeat three more times, so I'm going to have 0 to 9. Let's see if it works. Yes, it gives me all the IP addresses. But I want to see only the IP addresses. No need to see the entire line. Grep O, lowercase o, that means only. I want to see only the pattern that I'm looking for. And here we are. It's out of order, pipe sort. And now I'm seeing in order. I want to see only the unique IP addresses. Unique. Those are the unique addresses. And now I can direct all this information that was filtered into a file. I want to put on my home directory a file called attackers.txt. And if I print attackers, here we are. So that's all for today. Have fun in your studies. See you next time.